I'm live right now. I'm gonna be right back. 1 second. I'm live right now. I'm gonna be right back. 1 second. Okay, we're live on YouTube. Fantastic. All right, welcome everybody to our, what is this, our second technical talk of the day. We have Brantley here from ENS. We're really excited to have you. Really excited that you're a part of the hackathon. Yeah, here to explain why your dApp isn't finished until you add ENS.
Exactly. Great. Well, thank you very much. So my name is Brantley Milligan. I work for an organization called True Names Limited, which is a nonprofit organization, which is the de facto manager of the open source project, Ethereum Name Service. So we don't own ENS. It's a self-running open source project. We just manage it, of course, and promote it. There's the GitHub, our website, and of course, the lead developer and creator of it is Nick Johnson, good guy. So I'm going to be talking about what is ENS, then how it works, and then how to integrate it and use it in your dApp, because as Patrick said, your dApp isn't finished without ENS. So ENS, of course, stands for the Ethereum Name Service. We're going to talk about what this means. So how is it a naming service? A lot of people don't understand internet naming. It's like a thing lower on the tech stack that just works. And so a lot of even tech people don't understand how it works. So we're going to talk about what a naming service is. So a naming service is just a lookup system. A lot of people overcomplicate this. They think it does a lot more than it really does. You just provide a name, it provides you with information. So your computer then might do something with that information, but that is separate from the naming service. So a naming service just has names, owner, some system who gets to control the information on that name and the information attached to that name that you can look up. That's it. So why do we have naming services? So because computer identifiers, are generally automatically generated. There's numbers and letters. They work great for software, but they're bad for humans. Humans, of course, want words in a in a socially contextual language. Computers are bad with that. So a naming service connects these two things. So ENS, of course, has names, owners of names, and records that can store any information. If you have a name, you could look up and retrieve its records and then do something with that info. So for example, this is a lot of people misunderstand this. Let's say you're sending Ether to an ENS name, let's say to Brantley.eth. You type in Brantley.eth, let's say into Coinbase Wallet to send Ether. Coinbase Wallet does a lookup of that name in the ENS smart contracts on the Ethereum blockchain. There's no transaction involved, it's free. They're just looking up off the blockchain. They grab the Ethereum address, they bring it back to their wallet, and then their wallet sends the transaction on the Ethereum network. This is why we're able to support all cryptocurrency addresses, Bitcoin, Dogecoin, Litecoin, everything. We're even able to support non-blockchain things. So if you send Bitcoin to Brantley.eth, the wallet just grabs the Bitcoin address, brings it back to the wallet, and then the wallet sends that just on the network with the address, but that just is all hidden away with this better user interface using the naming system. So why is it the Ethereum name service? It's not because it's a naming service only for the Ethereum ecosystem. It's because it's a naming service built on Ethereum. So the logic and records are stored on Ethereum, but it can store information relevant to anything. So one way I like to think about it is maybe your DNS server uses Linux, right? But it doesn't really matter. It's just the operating system that it uses. But of course, it can provide naming to a Windows computer or something like that, right? So Ethereum is just the back end. It does mean that you can do certain things with Ethereum smart contracts that are really interesting. I'll talk about later. But it can store and serve information relevant to any system, even if it has nothing to do with blockchain stuff, right? So why do we use Ethereum? So there's lots of other blockchains we could be using. So we use Ethereum because it's the best blockchain platform, we think, for doing a naming service at all. So advantages include a high security decentralization. you know, if we had like our own blockchain just for naming, we'd have to be bootstrapping the security. It would be far less secure, decentralized than if we were than Ethereum. So ecosystem infrastructure. So there's tons of infrastructure for the Ethereum blockchain that we don't have to reinvent. So like MetaMask, we're in MetaMask. People can use Infura. A lot of wallets are already connected to Ethereum. They don't have to like connect to yet another blockchain. Standards. So like all .eth ENS names are ERC 721 compliant. So we can plug into all this ERC 721 infrastructure. Programmability. An amazing thing about ENS being on Ethereum is that it makes names, internet names, programmable with smart contracts. It's like a revolutionary new thing. Again, if we were on our own blockchain, we would be completely missing out on this. And then of course, interaction with other smart contracts on Ethereum, even things that have nothing to do with naming. So you could like have a smart contract that says when this, I mean, I'm just making this up, but like when this DAI vault, you know, gets liquidated, then automatically transfer this .eth name to this person or something. You can do all that because ENS makes names composable in this whole internet ecosystem. I'm sorry, this internet, the smart contract ecosystem. So ENS uses Ethereum to serve the internet, including and beyond the Ethereum ecosystem. Our goal is to make ENS, and because ENS runs on Ethereum, so ENS and therefore Ethereum, a basic piece of internet infrastructure used widely by people, whether they are part of the blockchain community or not. That is our goal. And we're doing this by complementing the DNS tech stack in parallel, expanding the capabilities of the existing DNS namespace, focusing on use cases not served by DNS, in some cases not possible on DNS. So we very much see ourselves as, we're not in competition with DNS. We think that's a bad strategy. DNS works great. It's used by the entire internet. We just want to expand its usefulness. I'll be just talking about what we mean by that. So how does ENS work? So again, paradigm shift, right, with blockchains. ENS proper has no servers. We don't run anything. Like our manager user interface, we run on a web server somewhere, but that can also be hosted on IPFS or other places. But ENS itself, like the smart contracts, don't run on a server anywhere. We are not a gatekeeper. There's no API to access, you know, special API access. You need to access it. You can interact with it, register a name, do lookups without ever interacting with our organization. This confuses a lot of people. So even if you like want to interact with ENS or integrate it or use it for some use case, you don't even have to talk to us. I mean, like we're happy to help you and answer questions, but you can just do it. So this runs entirely as a set of smart contracts on the Ethereum blockchain. No permission need to use the system. You just need access to the Ethereum blockchain. So there are three basic types of smart contracts with how ENS works. So there's the registry. So it's a smart contract that holds the names, owners, resolvers, and also a TTL, which we don't really use right now. But if you're in the DNS world, you know what that means. It's a very simple smart contract. It just says, this is the name, here's who owns it, and this is where to get the records. That's what a resolver is. Then you have resolver. So it's just a smart contract that stores and serves records. We have something called the public resolver, I'll talk about in a second, which is our maintained kind of record set, which like 99.9% of people use, but you can make your own if you want. You can extend what we have if you want. And then we have registrar. So registrar is just a smart contract that determines how people can get names. So for example, for .eth names, those are dispensed by a smart contract, whereas as long as you send the right transactions to it with the right criteria, it will give you the name that you want if it's still available. This is very different than the DNS world where there's like a company that actually manages this. We don't. It's just all done automatically. Of course, if you want to make any change, if you want to do anything with ENS, you have to submit a certain type of Ethereum transaction, which includes gas fees, which are really high right now. That's what you need. Of course, lookups on ENS don't cost anything. There is no fee because you're not making any state change to Ethereum. You're just simply reading from an Ethereum node, which can even be your own local node. I run a full node on my computer and I can connect MetaMask to it and I can do ENS resolution with my own node, which is kind of cool. So what do ENS records look like? So I mentioned that you can create your own record set if you want, but of course, most people are going to be using the standard record sets that we manage. We call that the public resolver. Like if you register a .eth name, you're automatically set up with the public resolver, so you don't have to do anything. These are the record types we have. So we have an address record type for an Ethereum address. Then we have an other addresses, which is any other cryptocurrency address. Then we have a content record type that can store an IPFS hash, a swarm hash, or a tor.onion address. Then we have text records, which is just for any arbitrary information. So like if your project wants to have its own record type for something, you don't even have to ask us, just use a text record. And then we actually also support all traditional DNS records, although that's not supported in our manager UI, but those are there in the public resolver. If you want to see an example of what these look like, go to app.ens.domains and search for brantley.xyz. That's a name that I have. It's a DNS name I've claimed on ENS. I have set up with pretty much everything we support, so you can see that. I'll talk more about DNS names in a second. So let's talk about the namespace on ENS. So ENS, a lot of people think that ENS is .eth names. Totally wrong. Banish the idea from your mind. I'm sorry you ever thought that. ENS is naming infrastructure that can support any name. .eth names are just sort of like the native names we started with, the native to ENS names we started with, but our infrastructure can support any names very easily. It all works the same. So .eth is the native top level domain, what is what's called, or is name suffix on ENS. It has all the benefits of being blockchain native, but we're expanding the namespace available on ENS by simply integrating the DNS namespace that already exists. Again, we're not in competition with it. So we've already integrated .xyz names. So I mentioned I have brantley.xyz, .lux, .cred, .co, .art, .club, and the rest are coming very soon. So like .com, .io. These were kind of some special cases and some experiments. We're now rolling this out to the entire DNS namespace. To be very clear, let's say if you own brantley.xyz and you claim that on ENS, you don't get brantley.eth. That's a different name. Somebody else could own, that's a totally separate thing. If you have brantley.xyz and you claim it on ENS, you have brantley.xyz on ENS. This allows for very interesting use cases. So for example, I have a brantley.xyz on DNS points to a normal website. So you type that into your normal browser, just normal website. Then I also have that on ENS, and I have tons of cryptocurrency stuff. So you could like send me Dogecoin, let's say in Trust Wallet or something like this, to brantley.xyz. So it's from a user perspective, they don't even have to know that there's different systems in the background. As far as the user concerned is, I can go to a website at that name and I can send you any cryptocurrency and it all just works. You know, given the in the applications just know based on context of what you're wanting to do. I think that's revolutionary. I think that's amazing. So that's what we're doing. So how does ENS compare to DNS? So one, in terms of infrastructure, remember not the names, but infrastructure. One, simpler infrastructure. So DNS was the best of 1985 technology. It has this hierarchical server system. It works really well. It's been scaled. It's amazing. There's amazing people that keep it running that you've never heard of. ENS, though, is in many ways far simpler. It's just a few lines of code that run on the already existing Ethereum infrastructure. Of course, there's zero downtime. You can't DDoS attack it because you could even be reading it from your own local computer. That's a totally different paradigm. It's decentralized. It's censorship resistant. So like with DNS, your records always exist on a server somewhere that somebody is managing somewhere, like by a company or something, okay? What that means, there's pros and cons about that. What it means is that if there's something bad happening with that trusted third party can just shut it down. That's really useful for shutting down certain bad things on the internet. But it can also be abused because people can shut down good things on the internet. With ENS, it's a different paradigm where there's self-custody. Other people are not, you're not dependent on anyone else hosting your name records anywhere. And so that's a double-edged sword. So, but that is a difference. So depending on your use case, that could be very important to you. We have built-in cryptography in an individual ownership or a self-custody. So built-in cryptography, side story. Public-private key cryptography was invented in the 1970s. It was considered to be so powerful, such a breakthrough in cryptography, that the US government classified it as like a defense weapon. And so it was illegal for Americans to spread this technology to non-Americans. Like you could go to jail. And so this is why when the internet was being kind of really got going in the 80s, this was before the World Wide Web really made it mainstream, but when a lot of the bedrock stuff was set, it did not make use of public-private key cryptography in the basic protocols because it was illegal. Then there was this whole story in the 90s where Hal Finney, who was an early Bitcoiner as well, he was involved in a project called PGP, specifically to try to break this rule. And it's an amazing story. They eventually convinced the US government to like make it legal to use public-private key cryptography in an international context. And this was critical to the explosion of the internet in the mainstream, and like with e-commerce and all these things could not work without it. Of course, it's critical to blockchains because users ownership is based on public-private key cryptography. But it also means that all these early protocols didn't have it built in. So like DNS doesn't have that built in natively. Well, in the 90s, once this became legal, people said, well, let's add it on. And there's a system called DNSSEC, a DNS security extension, which is a system for doing it. The problem is just like not everyone uses it. It's not native to it. The internet's developed kind of without it. It's really hard once you get something used by everybody to get something to change to it. So all this was to say, with ENS, we have it built in. So this is a hugely beneficial thing. As a result, and for many reasons, we have better security. Of course, as I already mentioned, we have programmability and then interactivity with other Ethereum smart contracts, which are not possible at all with DNS. It doesn't even make sense, their architecture. And this even allows for interesting things like you can have an ENS name that you register, you set up the records, and then you can transfer ownership to an Ethereum address that nobody controls, like 0x000 or something like this. But that name still exists, functions, resolves, but nobody owns it, and literally nobody is able to change the records. Again, not even possible given the DNS paradigm, but it is possible in ENS. You can also have smart contracts own it, do things automatically. Totally new paradigm. So why is this? Why are all these things useful? So for ENS is better security and censorship resistance. This is really useful for cryptocurrency addresses because you're dealing with value transfer. You need higher security. And for IPFS websites, so far as that's a distributed file network, it's useful to have then a distributed decentralized naming system as well. Then programmability, I mentioned names owned by smart contracts or groups like a DAO can own it or multi-sigs, and then they can also be used as non-fungible items that plug into that whole ecosystem. Okay, so how do you integrate ENS practically? So you've got your dApp, you're working on that. You want to use ENS. What do? Well, the first thing to know is the goal. It's very simple. Every time a user might otherwise see a cryptocurrency address or content hash of any kind, they should instead see an ENS name. All these hashed things, they're terrible user, they're a terrible user experience thing. That needs to totally go away. There's no way the blockchain world is going to go mainstream if people have to look at these long strings of numbers and letters. Like imagine would the World Wide Web had been as successful if people had to type in the IP address to go to a website. No, it's not user friendly. So I say your dApp isn't finished without ENS because your dApp is not user friendly if you still have any exposed addresses or hashes. You should use ENS, and here's how. So the number one use case, our bread and butter, super simple, is cryptocurrency address forward resolution. So what this means is forward resolution is the user supplies a name, and then your application goes and gets some information like the IPFS hash to display an IPFS website, or I guess cryptocurrency address, so like the Ethereum address or Bitcoin address or something like that. So for example, you want to send cryptocurrency somewhere. Put in the ENS name, or you can still let them paste in an address if they want, but ENS name, you put it in, you go retrieve that address, and maybe just make it so they can check it, and then they can send it. Very simple. This is very easy to do with our libraries. If you go to our docs.ens.domains, if you're using a library, it's like one line of code to do this. Super simple. Second use case, Ethereum address reverse resolution. Now this only works with Ethereum addresses. This is reverse resolution, so the opposite of forward resolution. So with reverse resolution, in this case, the user has supplied you with their Ethereum address, and then you look up to see if there's a name attached to that you can then display instead. So for example, you log in to a dApp with like MetaMask or their Web3 browser. People often do this, like their username kind of is like their Ethereum address, and they usually like do this, like a couple letters, ... something, because it's really long. Terrible UI. Don't do this. You should look up, do a reverse resolution lookup. Is there a name? There is. Show that instead. We also, I'm showing a picture here. We also have a standardized text record for somebody to put an avatar. You can also look up to see if they have an avatar in their ENS records, and then I'll display that with the name as well. Much better. So usernames. You can use reverse resolution just like I said. You can also give users, let's say like subdomains. So get like your dApp.eth, and then you give every user a subdomain. Like Brantley is the man.yourdapp.eth. Oh, it's available. You give them the name. You can even set up help them set up reverse resolution, use that as their username. And there are projects using this, like Universal Login, Ethereum, others as well. So other use case, IPFS Swarm and Tor.onion resolution. So you want to make your dApp totally decentralized, upload to IPFS, put the hash in our content record. Now people can access that. So let's say you're in MetaMask Mobile, supports ENS and IPFS websites. You put in your dApp.eth, and it loads the website. So right now, there's ENS plus IPFS website supports in the MetaMask plugin. So if you're in Chrome or Firefox or something like that with the MetaMask plugin, you already have it. Just you can try it out. So make sure you put a slash at the end of it so that the extension can recognize it. We're also natively in the Brave browser, the Opera browser, MetaMask Mobile, Status browser, and others. Go to our website, ens.domains, and scroll down to our ecosystem section. You can see all the ways you can do this, but there are practical ways to do this. Let's say, though, one of your users doesn't have MetaMask or Opera. How can they access it? Well, we run a service called ETH, which makes it so that if you take a .eth name but add .link to the end, it resolves it like a normal website. So like, let's say almonet.eth, that is a directory of decentralized websites. If you do have MetaMask, you do almonet.eth/, and it'll resolve. But if you don't have that, do almonet.eth.link, and it will resolve like a normal website. We also support Tor.onion resolution. So if you're involved in the Tor community, you know that there's a Tor naming problem. We think we've solved it. So if you have the Tor browser and you have MetaMask enabled, because that's a Tor browser is Firefox based, so you can put Firefox extensions in there. You can put MetaMask. We've actually set up a couple to make it work. Type in DuckDuckGo Tor.eth. I set this up. Put a slash at the end. Hit enter, and it will go to the Onion Hidden Services version of DuckDuckGo. We also support DNS records. There's a project right now actually using this. So .cred is a DNS top-level domain that's also integrated in ENS, and they're actually using ENS and IPFS to store the canonical version of their DNS records, which is pretty amazing. They've also made it so that the owner of the ENS version of the name is the canonical owner of the DNS name. So if you have Brantley.cred, you can trade that around on the ENS version of it, and the DNS version follows the owner of that because you're able to log into their DNS portal with MetaMask, and they can check to see if you have the ENS version. So that's pretty exciting. And then everything we haven't thought of. So like we said, you can use text records, you can use a custom resolver. You know, what are we not thinking of? So these are some useful links, our various websites, and yeah, that's my presentation. So I think I saw there were some questions here. See, how do I look that up? Okay, so question number 1. So can we do handshake names on ENS? No, we do not support handshake. So brief thing about handshake. Handshake, smart people, good people, totally different project, very different approach to bringing blockchain technology to internet naming. Handshake is an alternative root project. So what that means is that they've created hundreds of thousands of new top-level domains and sold them to people. But you can't like use them in a normal browser because like a normal browser uses the ICANN managed DNS route that the whole world uses. So you have to have your computer use a different route, or you have to have a browser extension or a special browser or something like that. They are intentionally trying to replace the ICANN managed DNS route. There's this thing called a problem called name collision. So a name collision is when the same name is owned by different people and has different records depending on the system you're using. So name collisions are bad because they destroy the whole point of the usability of a name service. Handshake is intentionally creating a huge number of name collisions with the traditional DNS system, because their hope is that so many people will start using their root that they will become the de facto name system of the internet and replace the current DNS route in the way that that's managed. There's a nonprofit organization called ICANN that coordinates people from all around the world to manage that. There have been other alternative root projects over the years that have failed. I wish Handshake success. We personally think it's highly unlikely they're going to succeed. They're antagonizing the traditional DNS community a huge amount. But we're basically throwing in our lot, like I said, with the traditional DNS. We just want to extend that. We don't want an unnecessary fight with like the rest of the whole internet. We don't think that's desirable. We just want to extend the current DNS. Handshake is taking a very different approach to no, we don't work with Handshake. Okay. When you buy an ENS domain, is it automatically linked to the address that bought it? Are all domain transfers stored publicly on the blockchain? Okay. When you get, I should specify, a .eth name, register that, it is automatically, I mean, one, it's owned by whatever wallet registered it, because that's how ownership works on Ethereum. It's owned by an Ethereum account. We do then automatically set the public resolver and the address record with the Ethereum address that registered it. You can, of course, change that, the address record if you want, or even just delete it. And then you can also transfer ownership to somebody, to a different account if you want, by transferring what's called the registrant and then also the controller. If you're on our manager, you'll see that. And our domain, all domains transfer stored publicly on the blockchain. Yes, so it's all on the Ethereum blockchain, so it's all public. The history is all public. Did Makoto create ENS? No, Makoto is a great guy. He's one of our developers, but no, Nick Johnson created ENS, and a couple other people were involved early on, like Alex Van de Sande, and others who were at the Ethereum Foundation at the time. Makoto is one of our developers, though, and does great work, and also Jeff Lau and others. Could it be built on top of Matic to reduce fees? Good question. I don't know very much about Matic. I would say we have no plans to leave Ethereum, although we would like to maybe leverage some sort of layer 2 to cut down on fees. We're actually working with Chainlink to do that for claiming DNS names on ENS. It's kind of an expensive process because it requires verifying a DNS sec proof on chain. And before, when gas prices weren't very high, it was like $1 or something, but now it's really expensive. So we're looking to work with them to make that cheaper. Okay, I think I skipped one here. Do ENS names have more value than normal domain names? That is a subjective assessment. That's what you think. If I have myname.xyz on ENS, does it not mean it will work on web? Okay, so did something like go away or something like this? Okay. So the way DNS names on ENS work is that you have to register the DNS name on DNS first. Just the normal, like you go to Google Domains or something like that, or GoDaddy or whatever you want. And then you do a certain process to claim that on ENS. And so then you own both. And then it always, the ownership follows the DNS side because that's canonical at this time because we're just extending DNS. So you can't like own a name on ENS but not on DNS if it's a DNS name. It always follows that. Somebody says like google.com and youtube.com. I don't know what they mean. Okay, so are there any other questions or did I miss anything here? Somebody said thanks. Yes. I think that's everything.
All right, cool. Yeah, I'm not sure if thanks is a question, but show some appreciation to you. So that's great. Well, yeah, if it looks like there aren't any more questions, we just want to thank you, so much for being on and kind of going over ENS and explaining that, yeah, like your dApp isn't quite done until you put ENS on there. Again, ENS has been, wonderful, and they're sponsoring a couple prizes, like 5 at $150. And he explained it right here. It's really easy to get one spun up and get one on your dApp and apply for that bounty and opt into there. So yeah, thank you so much for being here. We're really excited, and this video will be going up on YouTube. So if you guys want to check back, you are welcome to go see it, and we'll see you more in the Discord.
Great. Have a great day.
Thank you so much.